Right now, buried beneath the floor of France and Switzerland, the most powerful machine humanity has ever built has gone quiet. It didn't explode. It didn't fail. It simply stopped. For years, deep in a tunnel longer than most cities, it hurled particles at each other at almost the speed of light, recreating conditions that last existed a fraction of a second after the birth of the universe. And then, on an ordinary morning, the beams were switched off, and a silence fell over the machine that had not been heard in a long time. That silence should unsettle you far more than any bang. An explosion is a problem you can point to. This is something stranger. The largest scientific instrument on Earth has been powered down, and behind that quiet lies a question its own creators are struggling to answer. After decades of searching and billions of dollars spent, the machine may have run straight into a wall that no amount of engineering can break through. For 100 generations, human beings have taken one simple idea on faith, that with enough effort we can always look a little deeper. This machine was the ultimate expression of that faith, and it may have just found the place where the looking stops. This is the story of a sleeping giant, of the triumph that made it famous, and of the eerie nothing it found next. And it may be the story of the moment physics itself hit a limit. To understand what has gone silent, you have to grasp what this thing actually is, because words like machine barely do it justice. It's called the Large Hadron Collider, and it is less of a machine than an underground cathedral built to worship a single question. What is everything made of? Every time it runs, it manufactures in a spot smaller than a grain of dust, temperatures hundreds of thousands of times hotter than the core of the sun. For a flicker of time, it turns a quiet Swiss valley into the hottest place in the entire solar system, a tiny echo of the fireball the whole cosmos was born from. There sits a ring buried in the earth around 330 feet below the surface, deep enough to hide a skyscraper laid on its side. Now, stretch that ring out to a circumference of 17 miles. A runner would need most of a half a marathon just to loop the tunnel once. Inside it runs a pipe emptier than deep space, colder than the deep space too, chilled to around minus 456 degrees Fahrenheit, barely a whisker above the coldest temperature that can exist, and colder than the dark between the stars. Through that frozen emptiness, the machine fires two beams of tiny particles in opposite directions and pushes them, using some of the most powerful magnets on the planet, until they are moving at more than 99.99% of the speed of light. At that speed, a particle laps the entire 17-mile ring more than 11,000 times every single second. To photograph the split-second aftermath of those crashes, engineers built detectors that are cathedrals in their own right. One of them heavier than the Eiffel Tower, packed with sensors and threaded with enough cable to wrap around a city. When the beams collide, these giants witness up to 1 billion particle crashes every second, unleashing a flood of data so vast that thousands of computers scattered across the world are needed just to sift through it. More than 10,000 scientists from over 100 nations have given their careers to reading what this machine writes. The emptiness inside matters as much as the cold. To stop the particles from colliding with stray air, the pipe they travel through is pumped down to a vacuum emptier than the space between the planets. Some of the emptiest, coldest space anywhere in the solar system now sits inside this ring, engineered by human hands, all to give two invisible specks a clear road to their meeting. Then the machine steers the two beams into each other. Think of two bullet trains sent screaming toward one another on the same track, except these trains carry the raw energy of the early universe, and the collision is exactly the point. In that violent instant, energy becomes matter, and brand new particles flash into being out of the wreckage, particles that may not have existed freely since creation itself. This underground cathedral was built to catch them, and for a while it worked miracles. Its greatest miracle came in the summer of 2012. After a search that had consumed half a century of theory and a generation of physicists, the collider finally cornered its most famous prey: the Higgs boson. This was the particle that gives all the others their mass, the final missing piece of our best theory of reality, the so-called Standard Model. The world's press called it the God particle. Champagne was opened. A Nobel Prize followed. It was one of the crowning achievements of modern science. For a moment, it felt like a beginning. The standard model, the rulebook describing every particle and force we know of, was finally complete. Every prediction it had ever made come true. Physics stood at what looked like the doorstep of a new frontier, ready to stride out into the unknown. And then something happened that almost no one had prepared for. Nothing. Physicists had expected the Higgs to be a doorway. Behind it, their theories promised a whole hidden zoo of new particles, exotic, heavy cousins that would explain the deepest mysteries left in physics. The machine was cranked up. Scientists searched and kept searching. Still, the new particles never came. The doorway opened into an empty room. It is worth being clear about what was supposed to be waiting there. For decades, the most beautiful idea in physics predicted that every known particle had a heavier, hidden partner, an entire mirror family of matter sitting just out of reach. Those partners would have revealed what dark matter is made of. They would have sealed the deepest cracks in our theories. The collider was built in large part to find them. It searched exactly where they were promised to be. The space came back empty. Think of an explorer who spends his entire life climbing toward the summit of an unmapped mountain, certain that a vast new landscape awaits on the other side. He reaches the peak, breathless, and looks out. And there's only fog. No new range, no hidden valley, just a blank gray wall of nothing, stretching as far as he can see. This is the situation particle physics quietly finds itself in. And among researchers, it has an unofficial name: the nightmare scenario. The Higgs and nothing else. A theory known to be incomplete, since it cannot explain the dark matter that outweighs everything we can see, and yet a machine that stubbornly refuses to show us what comes next. Billions of dollars, thousands of the brightest minds alive, aimed at the smallest things in existence, and the universe simply went silent, which raises a possibility far more disturbing than a broken machine. Because maybe the machine is not the thing that is broken. When an instrument this powerful is pointed at the darkness and comes back empty again and again, you eventually have to ask a heretical question. What if the problem is not the collider at all? What if the map we have been using, the theory we trusted to tell us where to look, is quietly leading us off a cliff? To see why, follow the money, and then follow the physics. Start with the money, because the silence has a brutally practical side. A machine like this is monstrously hungry. When it's running, the collider and its home laboratory draw as much electricity as a small city, well over a terawatt-hour in a single year, enough to light up hundreds of thousands of homes. That appetite is not just a line on a budget. Not long ago, when an energy crisis swept across Europe and power grids strained toward their limits, the laboratory was forced to do something telling. It powered the great machine down early and cut back its running time to spare electricity for the homes and businesses around it. A giant of pure science, dimmed to keep the lights on for everyone else. It was a quiet reminder that even the pursuit of the universe's deepest secrets has to answer to the electricity bill. And the cost of running it is only the start. Building the machine at all swallowed years of labor and a fortune drawn from dozens of nations. Every dollar spent chasing particles is a dollar not spent somewhere else. And for a project on this scale, the world is entitled to ask what it's getting back. When the answer for more than a decade has been the sound of silence, that question only grows sharper. So the current shutdown is not only about upgrades and repairs, it forces a far heavier question into the open. If the last machine, for all its power, slammed into a wall, is it wise to spend even more? Because the proposed successor, a collider several times larger, could become the single most expensive scientific instrument ever conceived. A bill running into the tens of billions. And no one, not one physicist on Earth, can promise that it would find anything at all. It would be the most expensive gamble in the history of curiosity. Spend a fortune the size of a nation's budget, carve a tunnel that dwarfs this one, and hope, with no guarantee of any kind, that the universe finally decides to speak. To switch this machine off and to hesitate before building its replacement is not just flipping a breaker. It is a civilization pausing to ask whether the answer it wants can still be bought. Now follow the physics, because there is a reason the giant may have gone blind. It comes down to a rule as old as the microscope. To see something small, you need the right kind of tool. To see something smaller, you need a better one. A collider is really just an enormous microscope. The more energy it can pack into a collision, the smaller the scale it can peer into. And this is the cruel trap. The deeper you want to look, the more energy you need, and the energy required does not rise gently. It explodes. To probe just a little further than the current machine, you need one many times its size and cost. We built a microscope 17 miles around, and it still may not be sharp enough to see the answers we are chasing. Some physicists have a bleak name for what may lie ahead: the desert. The fear that between the small scales we can already reach and the almost inconceivable scales where the final answers might hide, there stretches a vast, featureless emptiness, an energy wasteland with nothing new in it for an enormous distance. If the desert is real, then no collider we could ever afford would carry us across it. We would be left standing at the near edge of a gap too wide to leap. It is a little like trying to read the fine print at the bottom of a contract using a giant telescope. The instrument is magnificent and powerful and pointed at completely the wrong scale. The secrets we are hunting may simply live at energies that no machine humanity could ever build would be able to reach. For the whole of the modern age, nature has answered our questions, as long as we ask them loudly enough. This might be the first time it has simply refused to reply. And that leads to the most unsettling thought of all. Perhaps the machine is doing its job perfectly. Perhaps it's showing us the plain truth, and the truth is that our theories quietly took a wrong turn somewhere. That the elegant equations which predicted a universe full of new particles were, in some deep way, simply mistaken. If that is so, then the empty room the collider keeps revealing is not a failure of the machine. It's a message, and we have not yet learned how to read it. So, is this the end of a golden age of physics, or the strange and difficult birth of a new one? The honest answer is that no one yet knows, and that uncertainty is exactly where the real story lives. Both possibilities are staggering in their own way. One would mean we are running out of universe left to discover. The other would mean the next great revolution in science is hiding somewhere we have not yet thought to look. Either way, the comfortable century of steady, predictable progress is over. The silence under the mountains is not the silence of defeat. It is the silence of a science being forced to stop and think and question the map followed for 50 years. The giant is not dead. In the coming years, the machine will be rebuilt, upgraded, and woken again, more sensitive than ever before. But it will open its eyes onto the same strange wall and face the same enormous question that no upgrade can dissolve. This machine, it is worth saying plainly, is not dangerous, whatever the darker corners of the internet like to claim. It threatens no reality and opens no doorways to other worlds. Independent reviews have confirmed as much many times over. Its only real power is knowledge, and that is what makes the silence so heavy. The machine does not put our safety at risk, it puts our certainty at risk. For 4 centuries, humanity has assumed that if we just built a bigger instrument, nature would surrender its next secret. The great machine sleeping beneath Europe is the first serious sign that this bargain might have an end, that there may be a floor to how deep anyone can dig, a horizon on how much of reality we are ever allowed to see. And if that floor has truly been reached, then the most important discovery of this machine may not be a particle at all. It may be the outline of the limit of human knowledge itself. If a silent giant hiding a threat we can barely measure pulls at you, there is another one being watched at this very moment, and its silence could reshape the climate of the entire planet. We followed it in our video on what the Greenland tipping point will do to Earth. Watch that one next. Stay insanely curious.